Welcome back. The methods we're going to talk about when it comes to sets are right here. It looks like a lot, but they're quite similar, so hang in there. I have two sets for us. Our my set, which is 1 through 5, and then your set, which is 4 through 10. Now, let's go one by one and see what these methods do. And if you've ever seen Venn diagrams in your school, for example, two circles that are overlapping each other, what we're about to do is quite similar to this. The first one is difference. And sets are very useful when having two sets and comparing them to each other. So for example, in here, difference simply says my set dot difference, and we give it another set, such as your set. If I print this right here and I click run, I get 1, 2, 3. It's going to find the difference of the first my set with your set. So any duplicates between the two, which is 4 and 5, gets ignored, and it only shows the difference, that is 1, 2, 3. What's different between my set and your set when viewed from my set? Well, your set doesn't have 1, 2, 3. What about the next one? Discard. Again, if we do my set dot discard, it says it removes an element from a set if it is a member. So here we can say discard 5. And if I do print my set and I click run, I get none. But if I print here my set and I click run, I get 1, 2, 3, 4 because we've just discarded 5. It modifies our set. Just to keep our working space clean, I'm going to comment these out. Next is difference update. So I'm going to say my set, and then once again, let's see what difference update does. Remove all elements of another set from this set. So if I do your set here, and once again, I do print, and I click run, I get none because it just modifies my set. So remember, we just have to have our print, my set, and now this my set is updated with just 1, 2, and 3 because we're updating it so that the differences are removed. So 4 and 5 are removed. Unlike difference, where it just told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here, but then my set bottom was modified because of difference update. All right, a few more to go. Intersection. And this one, once again, my set. And in here, once again, let's read what it does. It just has intersection with something else. Well, let's find out. If I do your set here, and I do print, and I run this, it's going to give me 4, 5, because that's the intersection, the two common things that my set and your set has. What about is disjoint? Well, if I do my set, and then your set, I feel like I'm saying those words over and over. Hopefully that's not too annoying. And then here, if, let's comment this out, we run this, I get false. Is disjoint simply says, hey, are those two circles overlapping? Do they have anything in common? If, for example, my set didn't have 4 and 5, and I click run, I get true, because is disjointed means these sets have nothing in common. Awesome, just a few more. The next ones we're going to see is subset and is superset. But actually, before we do that, let's do union. Let's see what this does. Union will say my set, And in here, we want to add the other set, your set. If we print this and click run, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did that just do? Well, Union just united these sets together, but removed any duplicates. That's kind of nice. And as you can see, it created a new set for us. It returned a new set. By the way, there's actually a shorthand that you can do here in Python, which is the shift and then the key above your enter, which is right here, this straight line. So shift and then the backslash, but if you press shift, you'll get this little straight line. If you print this, well, remove the brackets here. Let's run again. And you see that works as well. And by the way, this also exists for intersection. Again, you don't see it that often, but with intersection, you can do the same thing where you just do the end. And if you do that, it gives you the intersection of my set and your set. All right, I promised you this is going to be short, so 2 other ones. Is subset and is superset. As you can imagine, my set, if let's say my set only has 4 and 5, and I say, hey, is my set, is that a subset of your set? And I print this. If I click run, it's true. My set is a subset. That is, it's inside of the circle of your set because 4 and 5 is inside of it. So my set, the entirety of my set is inside of this other set, which we call a subset. On the other hand, we also have this idea of superset. So if I do, instead of is subset, is superset, I'll get false because, well, my set is not a superset. It doesn't encompass your set. It's the other way around. Your set is a superset of my set. Because your set encompasses everything that my set has, which is 4 and 5. Oh boy, that was a lot. And you're asking yourself, there is no way I'm going to memorize any of that. Well, good. I don't memorize any of this either. As a matter of fact, I usually go to the Python documentation or just Google around. And because I know sets exist, if I ever want to compare, let's say, 2 sets, I know to just go here and find the tool that I want. That's the key of a programmer that I keep mentioning over and over. It's not memorization. It's the ability to know that there's tools that you can use and being able to Google for them. I know it doesn't sound exciting because in movies you see everybody typing super fast and coding everything, but that's just not real life. In real life, you just Google around, find solutions because by now you know what sets are, you know what sets can do, so that you can Google for methods that are appropriate to your problem. I'll see you in the next one. Bye-bye.